Welcome to section 8.3, day 1, multiplying binomials. So multiply a binomial by a binomial or a binomial by a trinomial. So one of the methods we have for multiplying binomials is using the distributive property. And to do the distributive property, we're going to distribute the x to x plus 3, and then we're going to distribute the negative 4 to x plus 3. And to show that we're using the distributive property, we would do this. We would have x times x plus 3, and then negative 4 times x plus 3. And then we would do what we've done before. We're going to distribute the x into the x plus 3. We're going to distribute the negative 4 into the x plus 3. And we get this. X squared, x times 3 is 3x. And then negative 4 times x. And then negative 4 times 3. Then we combine any like terms, and we make sure we write from highest degree to lowest degree. This is x squared. 3x minus 4x is a negative 1x, or just negative x, and a negative 12. This is the answer when we multiply x minus 4 times x plus 3. And this is a quadratic trinomial. Do the same thing to demonstrate distributive property. We take the first term, multiply by y plus 2. We take the second term, which is a plus 5, and multiply that by y plus 2. We bring our y into the y plus 2, we get y squared plus 2y. We multiply 5 into y plus 2, we get plus 5y. 5 times 2 is 10. And then we will combine any like terms we have. Highest degree to lowest, 2y plus 5y is a 7y. And we bring along the 10. And there we have our answer when we multiply y plus 5 times y plus 2. This is our simplified form. And notice when we say simplified form, there are no parentheses left. The next one, we're going to do the same thing. We're going to have 3m. We're going to multiply it by 2m minus 4. Then we're going to take the minus 1 and also multiply it by 2m minus 4. So 3m times 2m is 6m squared. 3m times negative 4 is negative 12m. Negative 1 times 2m is negative 2m. And negative 1 times negative 4 is a positive 4. And then we combine our like terms. Highest degree is first, to put them in standard form. Negative 12m minus 2m is negative 14m. This is plus 14. And this is my simplified form. You notice that these ones, all of these, when we multiply a binomial by a binomial, these ones all turned into quadratic trinomials. It does not always happen that way, but this ones, they did. All right, that is one way to do it, was the distributive property method. Another way to do it is by what we call the FOIL method. This is just a mnemonic to help you learn how to use the distributive property. Basically, the FOIL method technically only works for binomials, but the concept behind it works for everything. All right, so FOIL, what does it stand for? FOIL stands for first. So what you do is you take the first terms and multiply them together. And I'll demonstrate here in a second. The O stands for outer terms. You multiply the outer terms together. The I stands for inner. You multiply the inner terms. And then you do the last terms. So what does this look like? I'm going to use different colors here so you can see. So the first thing it says is multiply the first terms together. We take x times x. X times x is x squared. Then we take the outer terms, and the outers are the x and the 5. X times 5, which is 5x. Then we take the inside terms, which is the negative 7 times x. They're the ones that are in toward each other. This is negative 7x. And then we do the last terms in each binomial. And the last terms in each binomial are negative 7 and 5. We multiply them together, and we get negative 35. Then we do just like we did on the previous slide. We combine any like terms we have, work from the highest degree to the lowest. So we have x squared, then we have 5x minus 7x, which is negative 2x, and minus 35. This is my simplified form. This is using the FOIL method. It's similar to what we would have done if we would have written this out using the distributive property, but instead of having to rewrite it, we can use this method, and sometimes you'll hear me call it the rainbow method, because we draw on the lines and it looks sort of like a rainbow when you use different colors. If you do this, it works just the same as the distributive. Most people prefer this. So I want you to try the FOIL method on all of these. See if you get the same answer, so pause your video and see if you get what I get. So for the FOIL method, the first thing we do is the first terms, y times y, which is y squared. Then we do the outside terms, the y and the 9, which is 9y. Then we do the inside terms, negative 8 times y, which is negative 8y. And then we do the two last terms, negative 8 and 9, which is negative 72. We then combine like terms. We have y squared, 9y minus 8y is y, and the negative 72. And there's your simplified version. For the next one, again, we take the first term times the first term. We get 3x times 5x. We get 3 times 5, which is 15. X and x is x squared. Then we take the outside. 3x and negative 1 is negative 3x. Then we do the inside, inner. Negative 4 times 5x is negative 20x. And then the last, negative 4x times negative 1, which is positive 4. Combine any like terms we have. Always go from the highest degree to the lowest. Negative 3x and negative 20x is negative 23x plus 4. And there is my simplified form. All right, going to the last one. Again, we take the first term times the first term. We get 7x squared. We take the first term times the last term, so the outer terms. The O for outer, x times negative 2 is negative 2x. Then the inside, inner terms, 11 times 7x is 77x. And then the last terms, 11 times negative 2, which is negative 22. This becomes 7x squared. Negative 2x plus 77x is 75x minus 22. And this is my simplified form. All right, here's a quick review. We want to write each polynomial in standard form, and then we want to name each polynomial based on its degree and number of terms. First thing we do is write them from the highest degree to the lowest degree. Our highest degree is the power of 2, so that comes first, negative 2x squared. We have a 5x. There's only one of them, so we have 5x. That's our next highest degree, and then our constant has a degree of 0. Remember, it's our last term. And we would name this using our special names. And anything raised to the second power as our highest degree is a quadratic. You're going to want to remember that one because we're going to use quadratics throughout the rest of the year. And this has 3 terms, so it's a quadratic trinomial. All right, next we have 8 minus 3y. We look for the highest degree. The highest degree is of 1, so we're going to bring this term first, negative 3y plus 8. This has a degree of 1. We've seen equations like this, and if you would graph this, you get a line. So this is called linear. We have 2 terms, so it's a binomial. It's a linear binomial. And the last one, we have 10x cubed. We have 1 term. It's already in standard form. It has a degree of 3, and we have a special name for that, which is cubic. Remember, the degree always comes first, so cubic monomial. So that is a refresher on how we name our polynomials based on their degree and their number of terms. That is all for section 8.3 day 1. We are learning how to multiply binomials together, either using the distributive property or the mnemonic FOIL. Multiply the first, then the outer, then the inner, then the last. Thank you for watching and have a nice day.